Welcome back to Geometry, Measurement, and Probability. In this video, we will pick up in section 13.1 with the triangle inequality. So let's get started. We talked about the triangle inequality in chapter 12, and we reviewed the triangle inequality here in chapter 13. The triangle inequality says that the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. In example 4, we want to know, can sides with the following lengths form a triangle? Look at part A. We start with our first pair. So 14 plus 6, is that greater than 8? Yes, 14 plus 6 is 20, and that's greater than 8. Now we move to our next pair. So let's look at 6 plus 8. Is that greater than 14? Well, 6 plus 8 is 14, but that is not greater than 14, that other side. This one cannot be the lengths of the sides of a triangle because it has to be greater than, not just equal to, the third side. Look at part B. Start with your first pair. 3 plus 5, is that greater than 7? Yes. Look at the next pair. 5 plus 7, is that greater than 3? Yes. Then look at your last pair. 3 plus 7, is that greater than 5? Yes. And so these could be the sides of a triangle. Perimeter is the length of a simple closed curve, or the sum of the lengths of the sides of a polygon. In other words, perimeter is the distance around. In example 5, we are asked to find the perimeter of our shapes. So for part A, we're going to add those three sides of the triangle. So we have 3 centimeters plus 3 centimeters plus 3 centimeters. 3 plus 3 plus 3 is 9, and our units here are centimeters. Now, by the way, as you write a number and a unit, make sure you have a space between the number and the unit. Look at part B. Our perimeter is W plus L plus W plus L, the distance around the rectangle. When we add our like terms here, we get 2L plus 2W. This may be a formula that you've seen before. Look at part C. We have a square. Each side has length S. So our perimeter is S plus S plus S plus S, or 4S. Again, you may have seen this formula before. Now look at part D. There's a catch in part D, because notice here that not all of our units are the same. Before we can find perimeter, we need to convert our units to the same unit of measurement. So I'm going to choose to convert the millimeters to centimeters. Let's start with 40 millimeters. Look back at your table of the metric system. We know that 1 millimeter is the same thing as 0.001 meters. And then also notice here, to change from meters to centimeters, 1 centimeter is 0.001 meter. Millimeters cancel out, the meters cancel out. Anything in the numerator we multiply, anything in the denominator we divide. So 40 times 0.001 divided by 0.01 gives us 4 centimeters. So the 40 millimeters is the same thing as 4 centimeters. Now look at the 60 millimeters. I use the same conversion factors that I just used. In 1 millimeter, there are 0.001 meters. And there are 0.01 meters in 1 centimeter. The millimeters cancel out, the meters cancel out, and I multiply. 60 times 0.001 divided by 0.01 gives me 6 centimeters. So 60 millimeters is the same as 6 centimeters. Now all of my sides have the same unit of measure. So to find the perimeter, I add 3 centimeters plus 1 centimeter plus 3 centimeters plus 4 centimeters plus 6 centimeters gives me a total of 17 centimeters. Again, notice that I have a space between my number and my unit. A circle is the set of all points in a plane that are the same distance from a given point, called the center. The perimeter of a circle is called the circumference. And pi is the ratio between the circumference of a circle and the length of its diameter. So pi is 22 over 7, or we shorten that to 3.14. Pi is what we consider an irrational number. It's a decimal that never stops and never repeats. But many times you'll see pi rounded to 3.14. The formula for our circumference is pi times d, or pi times the diameter. Another formula we can use is 2 pi r. Remember that 2 times the radius equals our diameter. We also have a formula for arc length, and you'll see that formula in your notes and on your screen. In example 6, in part A, we're asked to find the circumference of a circle. So here's my formula, C equals 2 pi r. Plug in 2 meters for the radius. 2 times 2 is 4 meters. Read your directions in Math Labs carefully. Does Math Labs ask you to round pi to 3.14? Or you do have a pi button on the calculator. Type 4 times pi, or 4 times 3.14, and you end up with 12.57 meters. Whether you use the pi button on the calculator or 3.14, you get approximately the same answer, but the decimal places may be slightly different with each one. In part B, we're given the circumference and asked to find the radius. I start with my formula, C equals 2 pi r. Our circumference here is 15 pi meters. Bring down the rest of your formula. Divide both sides by 2 pi to solve for r. On the right side, the 2 pi's cancel out, and on the left side, the pi's cancel out. 15 divided by 2 is 7.5, and so our radius here is 7.5 meters. In part C, we're asked to find the arc length, and we're given the diameter. Our formula for arc length has r, the radius. So first, we need to figure out the length of the radius. Our diameter is 2 times the radius. Our diameter here is 10. Divide both sides by 2, and our radius is 5. Now, plug in 5 into your formula. We're also going to plug in 25 for theta, which represents the degrees of our circle. Type this into your calculator, pi times 5 times 25 divided by 180, and we get 2.18. Our units here are centimeters. Look at part D. Here we're asked to find the radius. We're given the angle and the arc length. First, here's our formula. Our arc length is 154. Plug in 87 for the angle, that's the theta. Multiply both sides by 180 to get rid of the fraction. On the left side, we have 27,720. To solve for r, divide both sides by 87 pi. When you type the left side into your calculator, you're going to type in 27,720 divided by 87 divided by pi, and you get 101.42 centimeters.